In this episode, I'm going to look at a Linn Magic DS1. This is a digital amplifier, it's an analog amplifier with DA converter built in, and it'll accept streaming formats, all the different formats. It's got a bunch of optical and coaxial inputs and stuff. This one is not a Chinese one. No. This one's made in Scotland, and it's completely dead. Let's see what's wrong with it. This is the Linn Magic DS1. Yes, Magic DS1. Made in Scotland. It's totally dead. So it doesn't do anything. I plug in the power, nothing. No clicks, no light, no nothing. So we're going to pull this one apart and see whether it's something relatively minor. This unit's held together with Torx screws. So we'll remove the 4 Torx screws, and that should lift the top. Then we check this out. This is a modern unit. It's not a vintage unit. So there's a good chance this will be a Class D amplifier. I guess we'll find out when I get it apart, because I've never been into one of these ones before. Here's the unit itself. Oh, excellent. It's not a Class D. It's a Class AB. Here's your outputs here, right? And looks like a Class AB design. Anyway, it's got a switching power supply. That's where we have to start because it's dead. So let's just take a look at this switching power supply and see why it's dead. So we'll first check it and make sure that it's actually getting AC power, which it is. So make sure that it's actually getting power through the power switch. Which it is, because the switch is on now. We'll see if there's any DC voltage being produced whatsoever. Which I don't think there is going to be anything, because I'm sure that that's where the fault in this lies, is in this switching power supply. Something's not working. I'm looking at this unit and I can't help but see this. What the heck is that? Oh, I guess that's heatsink gel for the MOSFETs. It looks like a wire sticking out of there, but it's not. That's just the heatsink transfer gel. See if there's any voltage here on any of the transistors, the MOSFETs. Power's off now. I'm just looking for a discharge. So there's some power on these. .82 volts between these. So there's power getting to the unit, but it's not running. And I think this is probably the standby transformer down here for the remote control. There's probably 2 separate power supplies on this. There's going to be a main supply and a standby supply. And of course, if the standby supply is not working, the main supply is not going to work either. I have the power board out now. I'm just going to go over a few of these connections between these two boards where the two of them interconnect together, because a few of these connections just don't look great. So we're going to check them out first, and then we'll see if we can get this power supply board to come to life. So I got B plus coming in. I'm just looking for any of my low voltages, which I should have somewhere along the line here. There should be standby voltages. I'm pretty sure it's probably this pin here. What's that come off of? It's coming off this coil up here too. There's 63 volts there. Okay, that's the primary of the standby transformer. This will be the primary of the main transformer over here. Like the first place I should start looking on this is maybe some of these electrolytics in the standby supply. That's, I think, the first thing I have to consider is that maybe some of these have gone bad, and that's why this thing's not starting. Especially since we look down here, this looks like this has been reworked before. I'm just looking at the board here, and this looks like it's been hand soldered. If you look down at this cap here, for example, these two look like they've been, actually all three of these three all look like they've been redone. And if I turn over the board here, you'll see that this capacitor looks like it's been removed, which it would have to be to get to those capacitors. So I'm going to remove this cap, and I'm just going to check those ones because I can't get any probes down there to check it as it sits. So I'm going to pull this cap out here, and we'll take a look and see whether that's where the fault is on this power supply. You see what I mean? If we look around the base of these filters here, they look like they've been replaced maybe with a heat gun or hot air, because the bases are melted here. Which, I mean, this is the MOSFET, right, to drive this transformer, and we have nothing coming out of this. So this is the oscillator circuit here that drives this. So I have to think maybe something in one of these three caps might be problematic. So now I can get in here with my meter, and we'll test and check the ESR of these caps and see if the ESR is any good. So we'll check the ESR. We'll try this one first. If we can get in here. .14, that looked like. How about this one here? 0.39, I think that's okay. What about this one down here? That one might be open. But this cap looks like it might be open. Yeah, I believe that one might be shot. Let's just try taking that one out and changing it. It's a 22 microfarad. So I'm sure I've got something I can put in there. And we'll see whether that does anything to this thing. Whether that'll get this power supply working. That'd be kind of cool if it does. Okay, there's the cap out of the circuit. We'll measure it again. See whether it tests any different out of the circuit. Okay, let's get the meter going here. Meter zeroed. And here is the capacitor. I do believe that that's open. I wonder if it's that simple. Wouldn't that be neat? Let me go find one. We'll try that out and see whether that's all that's wrong with this Linn amplifier. So I don't have a surface mounted crappy cap. So I'm just going to put a regular high temperature capacitor on the board here. But that's okay. We got lots of room here to mount this. There's one side of it. The other side down here. Double check to make sure it's properly soldered. Give a little more solder on there just to make sure. There we go. Okay. I can reinstall the main filter. Okay, we'll just mount this back in the chassis here to put the heat sinks back in place, just in case it does start.
Now that's what you call positive thinking.
Okay, that's in place. Drop a couple screws in here just to hold it in place. And then we'll try powering it up. I can remember what I did with that screwdriver. There it is. I won't put all the screws in it right now, just the couple that'll hold the heatsink in place until I know if it works. Okay, I can connect the switch. I'll plug in the power and see whether this thing makes any noise. Okay, turn on the power, see if we hear any relays click. Ah, I heard a relay click there. That's a good sign. Oh, you know what? It might help if I plug the power in to the main board. It might help, right? Hey, we're getting relays clicking now, which is good. That means that maybe the thing's going to turn on. Power. I got lights. I got lights. I got lights. I don't know what that means. I think that means that it's turning on. Cool. We're just gonna let this thing power off, and I'll put the rest of the screws in it so we can test it, and I can give this guy a call and I'll say, oh, by the way, you know that receiver that you dropped off this morning, I fixed it. Make this guy jump for joy because he drove a long ways to bring this out to me. This is a referral customer, and I did a service, I think, on that Scott receiver that I put all the light bulbs and stuff in a couple weeks ago, and then the same fellow brought me his VCR, and this is his friend's. And it looks like we've got this one ready to go. Okay, I got the unit hooked up to speakers. I've got my audio source going into it. Power. Got light lighting up here. And turn on the power. I guess it's initializing. Okay. Okay, now it's initialized. Analog audio in. Make sure the volume's not cranked all the way up. And we'll switch to analog, one of the analog inputs on here. That might be it. This fella told me, he said, he says that the British equipment has a different sound to it. And the guy that owns this, he's actually a guitarist, and he's got British amps, and he's telling me, he says, the British stuff's got a different sound to it. Just playing this MP3 player through here, through these little JVC speakers on, I can hear it right now. It has a different sound. It's just... What makes these amplifiers a little different than a lot of the amps that you find is the way that the outputs are set up here. Now, I've never seen this type of design before, but basically how it works is the IC output drives your speakers at low power levels. So you get, it's a monolithic output IC. And so you get the accuracy and error control that the monolithic ICs provide, but then it hands over to the standard output transistors when you get to louder volumes. So it's kind of like how Technics did their new Class A, where they would switch back and forth between a Class A and a Class AB. This is the same type of design, where it's using, I guess this is probably the Class A output, and then it hands off to the push-pull for louder volumes. And I'm just going by what I read, because I quickly Googled this amplifier to see what the heck it is. I wish there was service data, but there's none. I was looking to see if there was a schematic, but no luck finding a schematic. Just found an owner's manual and stuff and a description of how it operates. So I was working blind on this thing, but I knew that I had no standby supply because my relay and stuff wasn't kicking. So I knew I didn't even bother to look at this section. It had to be in here, and I figured it was going to be one of these caps that went bad, and I was pretty darn sure it was going to be one of these three that were in here. And see, I couldn't measure these ones because I couldn't get the probes in there until I pulled this capacitor out. But then see, the first one I checked was that one. The only one I've changed is that one, and that's solved my problem. You notice that I'm not touching this thing because I'm plugged into mains here, so I'm not going to stick my fingers in where there's 160 volts or so, and I'm not touching it while I'm pointing at this because I'm not on an isolation transformer when I'm working on this thing. This thing just draws too much current. If I plug this into my isolation transformer, I'm going to pop that fuse, because this thing will draw about 10 amps when it's putting out maximum power. At least it's a 10 amp fuse here, so if it's got a 10 amp fuse in on the mains, it's probably going to draw at least 9, right? It's not going to draw more than 10 because that'll blow the fuse, but if it was going to draw less than 8, they'd have an 8 amp fuse in there. So I'm going to say it's probably between 8.5 and 9 amps is what this thing's going to require when it's cranked up. Anyway, not much else to show you guys on this thing because this thing's fixed. But yeah, looking at this, the board layout, this is fantastic. You know, this is really, I'm really impressed. You know, I've never seen one of these units before. But that board is beautiful. Made in Scotland. And yes, very nice. Looks like it was made in 2010, so 8 years. But this is I'm impressed. This thing looks nice. Anyway, that's about all I can show you on this thing. It's an amplifier. It's got everything. It's got network and everything in it, so it's gonna have digital radio, I'm sure, built in on this thing. It's got SPDIF in it. SPDIF in. Well, here's look at the inputs on the back of this thing here. Okay, you've got a LAN input here. You've got RS-232. You've got SPDIF in and out. Toslink in, Toslink out. All these analog inputs and 2 speaker terminals and really nice binding posts. Those are just fantastic. Anyway, that's it. Thanks for watching. We'll catch you in the next one real soon. Now I gotta go make a phone call and make this guy's day. Thanks for watching. We'll catch you later.